Today our class deals with the basic class in Java, which is a string class. Now rarely we design a program, or really there's a program where we are not using the string. So it is one of the most used classes in Java. So we just try to understand what exactly the string, how you can create strings, how you can manipulate strings, what things are to be done and what things should be avoided when we are using strings. So the first part is how do we create a string. So string, as it is in class, so we'll create an object as we create for any other class and put the contents in this. Now there's another alternative to creating string, which is simply referring to the string in double quotes. Now this we call as a string literal. So anything within double quotes is referred to as a string literal. So this is the best way to more easier way to define a string as compared to this. And what is the problem in this, we'll just see in a minute. So the next important part related to string is that strings are immutable. Now immutable means that strings cannot be changed once they are created. So whatever content we allocate to a string, we cannot manipulate the string after it has been created. And what exactly does this mean, and what implication does this have? We'll just try to manipulate the string s2. Now for strings we have an operator which is plus. Now this we call as the concatenation operator. Anything you wish to add to a string, you can use the plus operator to add to it. Now suppose we need to add some content to the s2 string, so I'll write s2 is equal to s2 plus string. So we'll print this s2 to see what is the content in s2 right now. So we get this is string. So this gives us an impression that we have really changed the content of the string s2. But what exactly has happened? I'll just go through a graphical representation of this. We had a string referred to as s2, and the content of the string was this is. So as soon as we append something to this string, what really happens is that the contents of the original string, they do not change, rather it creates a new string with the complete contents, that is this is string, and as we have referred this string by s2, so s2 now, instead of referring to this, it will now start referring to this object. So any manipulation to a string will really lead to a new object, and one object will remain in memory which will be ready for garbage collection. So it is really not recommended that you manipulate the string too many times, because that would lead to a lot of memory loss. A lot of objects will remain in memory without use. So we have different alternatives for doing this. So first of all, we'll just clear the concept of immutability, wherein you cannot change the contents of the string, and whenever we change the contents, we get a altogether new object with the new contents. So the older object still remains in memory, but as we cannot refer to that, so that will remain as a candidate for garbage collection. Now another I can see an effect to this is, now instead of writing this, I can say s2. Now to concat something, we have a method So now what I have done is I have concatenated string to s2, and now I am again printing s2. So you see that the contents of the string s2 are still the same even after concatenating this string to s2, because we have not referred to the new string with s2. So s2 continues to point towards the older string. So this is the one part that we have cleared. I'll just put down. So one part is that strings are immutable. There are very reasons to this why strings are immutable that we'll come to as we discuss the next part. Now second thing is, what exactly is the difference between creating a string in this way and creating a string in this way? Now whenever the Java system, what it does is it maintains a string pool on the heap. Now what exactly is the string pool? The string pool has been designed to manage the string objects efficiently, because strings are immutable. So in case we have two string objects referring to the same content, what really will happen is, so I'll create another object string s3 and give it contents of this is same as s2, and I'll remove this and just see how this happens. So in this case, let us see what happens when we execute line number 2, which is s2. Now this is the string pool. Now when we write the line s2, a string object with contents of this is written to the string pool. This is the string pool. Now whenever we execute this line s2, this is a string literal which is written to the pool and is now being referred to by s2. So when you write line 3, which is s3, the system first tries to look for this literal on the pool. Now in this case we already have this literal on the pool, so instead of creating a new object on the pool, it will refer this very object that is already added to the pool by this s3. So s3 does not create any new object, it is referring to the old literal that was put to the pool by s2. However, there is a difference in line number 1. What exactly this does is, this does not refer to any object on the pool, rather it refers to some object on the heap, but it also adds our object to the string pool. So this will add an object with content this is string, to the pool, but the reference s1 will refer to an object which will be created on the heap rather than in the pool. So this creates two objects, one on the heap and one in the string pool, and s1 will refer to an object which is on the heap rather than on the string pool. So it is always better if we create string literals rather than creating a string object through this constructor. So I hope this concept of string pool is clear. However, there is a small addition to this is, if we make any change to this string, to any string literal on the pool, then this will no longer remain on the pool and the object will shift to the heap. That will come to when we'll see equals operator in case of Java strings. So we have seen two things, that strings are immutable, and second point, we have seen that Java maintains a string pool for storing string literals, and whenever we create a new object, it first checks for the literal on the pool, and in case it finds one, it does not create any new, it refers to this already existing literal on the pool with the new reference. So in case strings were mutable, this would mean if this literal is changed by any of the reference, it will affect all the other references that are also referring to this string literal on the pool. So we have one of the reasons for keeping string immutable is that because we are maintaining a pool of literals, so any change in this literal by any of the references, suppose there are 5 references to this literal, and any reference if it changes the value of this string, it will affect all the other references that are also attached to this literal. So this is one point we have seen, this which is very important, is that string pool is maintained by Java runtime to manage string literals. So any copy of any literal, in case we create another object with same contents which are already been added to the pool, we'll never have a new object created on the pool. We'll have the same earlier referred to by the new reference. So we have now the concatenation operator can be used to add anything to the string. Now adding anything to the string means you can add any data type to the string, as I can say s2 is equal to s2 plus, suppose I say 40 plus 40. So what output this will give us? So now we are concatenating s2 with a int. So whenever we concatenate anything with a string, that thing is first converted to a string. So I say this, and then the concatenation of a string plus string is operated, and then the result is generated. So in this case what happens is s2, as it is, this is first it will add this is plus 40, this will become this is 40, and then this is 40 is then concatenated with 40, we get this is 40 40. This is 40 40. So anything you add to a string will follow the rules of string concatenation rather than the int concatenation. So these two first add to become a string, and then the result is concatenated to this 40. However, in case I do the reverse, so now what happens is 40 plus 40, it is int plus int. So int plus int, the result will again lead to an int. So this will become 40 plus 40, 80. 80 plus s2 will become 80. This is 80. This is. So we must remember the concatenation operator with a string will always lead to a string. However, as with other operators, it will follow the rules as per the data type. However, as I had earlier demonstrated, that the concatenation in string should be avoided as far as possible, because it leads to a lot of wastage of objects, and we have different classes available like string buffer, string builder, that we can use to do manipulations to a string. Now what exactly happens when we add something to a string is, suppose I write s2 is equal to s2 plus hello. So this statement in fact is equivalent to creating a new string builder on s2, then appending hello to it, and then returning the string from the contents of the string builder. So we'll see the string builder class after we go through with string. However, just a demo of how this plus or concatenation operator is implemented in a string is that the Java runtime creates an object of the string builder class on the contents of the S2 object. Then it appends the contents that you are concatenating to it, and then for the entire content it converts it to a string, and we are again referring that content to S2. So this all is undertaken for every concatenation that we do. So this concludes our first part on string. We'll have much more to come for strings. So this clears the very basic part of string, that how we create a string. The two ways, string literal, or you can create through the new operator. Now new operator creates a literal through this, and then with the new operator it creates an object on the heap also. So this S1 continues to refer to an object on the heap rather than to the string pool, whereas these S2 and S3, as we have already seen, are objects which are on the pool and are shared by the same object.